Yes, Vijay ma'am, we can start.
Good afternoon, Murgan sir. Good afternoon, Radhika ma'am. Good afternoon, all dear friends. Am I audible?
Yes, completely.
Yes, ma'am, you are audible.
So, welcome you all to the session on retinal image analysis using AI. Okay. The speaker for this session is Dr. R. Murguan from NIT Silchar. So, Dr. R. Murguan is assistant professor in NIT Silchar, and sir's area of expertise is signal processing, image processing, medical image, embedded system, machine learning, deep learning, etc. Sir's Google Scholar citation is 26, H index is 3, I10 index is 1. Okay. Research interest is digital image processing, medical image, Internet of Things, multimedia compression techniques, machine learning, okay, deep learning, VLSI, embedded system processing, embedded signal processing. Okay. Sir has received an outstanding receiver award from Biomedical Signal Processing and Control from Elsewhere Journal on November 2016. He has received the Best Paper Award from International Conference on Advances in Engineering and Technology for the session Biometrics 2011. Okay. Again, he's received the Best Paper Award from National Conference on Information, Communication and Networking for the session Image Processing. He's invited as a reviewer in IEEE transaction on medical imaging, okay, biomedical signal processing and controls from elsewhere. He's received a Young Research Fellowship from DST Sub, Government of India for the project A Nationwide Study on Retinal Detachment in India with emphasis on the risk of the fellow eye through fundus image using deep learning. Okay. He's received a grant from research from DST Sub, AICT, NIT Silchar. Okay. Sir is authored around 59 papers in journal, conference and workshops, as well as he's authored nearly 10 textbooks too. Okay. So we are glad to have you as a speaker for this session. Okay. So over to you, sir.
Yeah. Thank you very much for nice introduction. And so I can share my screen. So yeah, is my PowerPoint is visible to all of you?
It's loading, sir.
Yes, sir. Is it visible? My PowerPoint is visible to all of you?
No, sir.
Not yet.
No.
Now it is visible, sir.
Yeah. Okay. So a very good afternoon, all of you, all the organizers and all the participants. And I wish you a happy new year to all of you in this virtual environment. Just 1 minute. Okay. चाबी चाबी साइन चाहिए ठीक है, थैंक यू। चाबी दीजिए दादा। चेयर है ना, एक चेयर फ्रंट वाला रख दिया ना, ठीक है, थैंक यू। So sorry for the interruption. So like Happy New Year to all of you, and we hope the 2021 may be given some new life to us, all of us. With this, we'll proceed this the today talk. So today I'm going to present the topic as as it is already planned, like the retinal image analysis. Of course, it is disease predictions in terms of artificial intelligence as well as the conventional image processing. So I have planned in both the ways, like both conventional as well as the machine learning perspective. Okay, this is the topic of our today talk. And so I belongs to this particular group of NIT Silchar biomedical imaging group. The today topic, like the today presentations, I'm going to deliver from the scratch because I don't know the level of audience. I hope the audience may be the teachers of engineering colleges. I hope so. Okay.
Yes, yes.
So
they are all faculties or research scholars in AI and ML.
Okay, then it will be very good. Okay, that is fine. Okay, so is anyone is working with this retinal images or retinal fundus images? Any of the audience or any of the faculty or research scholar, anybody is working with retinal fundus images? Or you may heard this retinal image analysis. We can take the retinal image is one of the research option. Have you heard this?
Yes, sir.
Okay, okay, that will be fine. Because I have prepared, I'm just prepared and I'm going to deliver this particular presentation from the scratch. So in that way, I think the today presentations will be helpful in two aspects. One is that if you don't know about this particular area, retinal image analysis, then it will be quite useful. So you can, pursue, you can select the new area of research. That is one way. Then another way is that if you heard or if you know, if you have some experience in the retinal images, then you will get some new research ideas, new research problem. So how we can further extend your area of research. So in that way, I have prepared this particular presentations. Let me proceed this. Before getting into the today topic, so I just want to highlight some of the historical informations that related to my institute where we are working. So I be working from this institute, the National Institute of Technology, Silchar, Assam. This is one of the NIT among the country. And this institute is started in the year 1967 as the Regional Engineering College in Silchar. And later, so it is upgraded into NIT according to the NIT Act. And as you know, as the technical teachers, so this is one of the technical institute and the institute of national importance as well. And this technical institute, they are offering many technical degree, say engineering, as well as the science and humanities, and as well as the Master of Business Administration, like management degrees. And the speciality of this particular institute, they have a large number of postgraduate and research program in this country, in this institute. Okay, as you know, this institute is recently ranked 47th among the engineering category by National Institute Ranking Framework in 2019. And of course, this is one of the top 10 NIT in the country, and as well as it is top 100 engineering in the country. Then apart from this institute is having a lot of infrastructure facility. Say like this school having the Central Kendriya Vidyalaya school in the campus, and we have the kids school in the campus for the betterment of the employers. And currently, this institute is headed by the director, Professor Sivaji Bandyopadhyay. He's a professor from Jadavpur University, Kolkata. So currently, he's leading this institute, and this is one of the like big and vibrant campus in the lower part of Assam. As you can see here, I want to share this picture for the audience because it is very quite, long. Because you and the audience, you are in the like in and around Mumbai, and I'm just sitting in the lower part of Assam, and I'm just delivering this lecture. So it's very quite, challenge to visit the campus. Even in the pandemic time, it is too hard to tough to visit the campus. But this picture, you can see the whole campus view of this NIT Silchar. This is one of the drone view of NIT Silchar campus. And everywhere you can find the natural, green beauty of the Assam state. And the speciality of this particular campus is that entire campus, so we have a lot of water reservoirs. So we have total 30 number of lakes in the campus. So in between the lakes, the buildings are constructed, and you can see the whole campus view. So I can tell you some of the building for attracting the people, the audience. Say here, you can see here, this is the main entrance of this institute, and the first building is the administrative secretariat of NIT Silchar. And the left side, you can see this is the guest house complex of NIT Silchar. And in between, we have all, academic buildings. You can see here the, mechanical engineering here. And here we have the workshops, and we have the electrical engineering, computer science, electronics, instrumentation, physics, chemistry. So all these academics buildings are center. And the entire right-hand side, you can see these are all complete hostel complex, students' hostels. And you can see the entire left side, you can see the faculty quarters. Okay. And you can see here up to the long view, there are 4 faculty quarters are there. And also we have the merit scholar PhD quarters also you can find here. And this is the whole view of this NIT campus. And you can see here in the long view, a lot of water bodies are there. Actually, there is one very big river. Actually, it is passing backside of the NIT campus. So the name of the river is called Barak River. So normally in the Assam state, there are 2 major rivers they are passing. One is Brahmaputra and another one is the Barak. And the Brahmaputra is passing the upper part of Assam. So in the upper part of Assam, as you know, the IIT Guwahati campus is there, and the lower part of Assam, the Barak River is there. And here the NIT Silchar campus is there for serving the local people of the state. Okay, so this is the whole the campus view of this campus. And you can see here, and this is one of the memorable building in this NIT campus. This is the central library of NIT Silchar. So the speciality of this particular library is that this is one of the largest library in South Asia. So this is the front view of this library. So the name of the library is that Dr. Bharat-Ratna Dr. APJ Abdul Kalam Learning Resource Center. This is one of the memorable building in this campus. And apart from that, so I want to highlight some informations which the department I belongs to. So I belong to this department, communications, electronics and communication engineering. So basically this department, we are offering 3 degrees. So the primarily like the technical institute, we are offering the BTech in electronics and communication engineering. And also we are offering 2 MTech program. One is microelectronics and very large scale integrations. And of course, we are offering communication and signal processing engineering. Then apart from these 2 MTech programs, this department is offering almost all the specializations for the Doctor of Philosophy degree, the PhD degree. Okay, so this is the these are all some basic historical informations which I want to highlight to the audience. So related to my institute and related to my department. Okay, now getting into the topic, so the today topic basically it is going to highlight the retinal image, right? So before that, I want to highlight some of the basic prerequisites for the better understanding of the audience. Okay, so let's begin with images. Okay, so let's say in every minute in our day-to-day activities, so the image is very, very important part of our life. Say after invention of this, the smartphone, quite it is very important. So every time, every minute, so we are capturing the memories through the images. But the statistics telling at least one picture we are taking at least in one day. So you can do that for taking the selfie, why we are taking the images for taking selfie, and we are capturing the sceneries, and much more purpose. Okay, so apart from this, so the images we can also utilize for surveillance. Okay, that is a major role everywhere. Okay, so we have everywhere in CCTV, the camera, so that can be utilized for the surveillance purpose. Okay, so after this kind of preliminary purpose, the images can also help for doing the research. Okay, so the research, it may be the medical research, or it may be a computer vision research, or any kind of research. Okay, so what I am just trying to convey, so the image is very, very important in the present lifestyle. Okay, so we have a lot of images, as we know, but even so this particular presentation, it is directly narrowed down into the medical images, because all these the medical environment, this health informatics, so all are working with these medical images. So how the medical images is going to help to the community or help to the doctors in the field of medicine. Okay, so in that way, so we can narrow down from these images into the medical imaging. Okay, so in short and simple, so how we can define the medical imaging or the medical images? It's a very simple. Say for example, if we have any some pain in our hand. Okay, so what we have to do? So basically, so we have to visit to the hospital or the radiological center, that will consult to the doctor. So if it is unfindable, then what they will say, they will suggest to go for the X-ray. Okay, so we have to undergo the X-ray for the defected parts of the body. Fine. So what informations they are taking from the X-ray? So they are taking the visual representation of the body. Okay, from the human body. So from the visual representations, the doctors or the radiologists, so they can suggest, so what is the issue and what is the problem, then how we can sort out the problem. Okay, so this is one kind of medical imaging, how we are acquire the medical images. So normally the X-ray machine or the X-ray image is one of the medical imaging modality to create the visual representation of the body. Okay, so in that way, so we can define the terminology medical imaging, it is nothing but a technique or a process of creating the visual representation of the interior of the human body. So for what purpose? It may be for the clinical analysis, or it may be a medical intervention. Okay, as well as so we can represent the function of the some organ or tissue or anything. Okay, so in that way, so the medical imaging is very, very important part of our life. Okay, so not only for this kind of X-ray images, but also we have n number of medical imaging modalities to create the visual representation of our whole human body. Okay, so here in this input, I'm just highlighting some of the medical imaging modalities here. Let's say here, I just highlighted very few medical imaging modality in this particular slide because these are all like frequently used in the hospitals. You can say first medical imaging modality, which is the radiography, or it may be, you can call it as the radiology. Okay, so which I just highlighted, this X-ray machine, this X-ray, acquiring of X-ray images. So that is comes under this category, like radiography or radiology, and like this kind of modality. So it's which include fluoroscopy, mammography, and etc. Okay, and we have the another very famous medical imaging modality is that we can simply we call it as in the hospital or the radiological environment, the CT scan. Like it is simply we call it as computer tomography. It is simple CT. Okay, so this is one of a very famous medical imaging modality which will be used in all conventional hospitals. Okay, so after this radiology and the computer tomography, so we have some set of medical imaging modality. Say for example, NMI, it is nothing but nuclear medicine imaging, and SPECT scan and PET scan. Okay, so these the specialized medical imaging modalities, say single photon emission computer tomography and positron emission tomography. So these are all very specific imaging modalities to acquire the internal organs of the human body. And so after this category, so we have a very specific imaging modality which is called magnetic resonance imaging. Okay, we call it as in MRI scan, or MRI imaging, like this. So this is a very special imaging modality to acquire the functionality of the human brain. Okay, and after this MRI, we have two more, special medical imaging modality, which is called ultrasound and Doppler ultrasound imaging. So normally these two imaging modality, which will helps to analyze the movement of the fetal, like the pregnant woman, the fetal of the pregnant woman. So this ultrasound and the Doppler ultrasound imaging. So I think this is very famous, which like always this kind of modality which is available in the all type of this gynecologist and other kind of hospitals. Okay, and the last two imaging modality, it is very, very specific modality because these imaging modalities, that fundus imaging and the optical coherence tomography, we call it as OCT. So these two imaging modality is going to help to acquire the retinal image of the human. Okay, so the last two. So the main difference between the fundus imaging and the optical coherence tomography is that the fundus imaging, it will acquire the two-dimensional images, and the OCT, it will acquire the three-dimensional images, but both are acquire the human retinal image. Okay, that is the speciality of this medical imaging modality. So here there is some connection of these last two medical imaging modality and this like on the today talk, because I'm going to talking about only this particular imaging modality today. Especially I'm just going to talk about the fundus imaging. Okay, I'm not going to highlight anything about optical coherence tomography. That is the separate, the different kind of research. So I'm just going to deliver only the fundus imaging modality here today. And apart from this, I have been working, my research group is working with other medical imaging modality also. Say, for example, I have been working with X-ray images, CT images, and I have been working with the MRI images and optical coherence tomography. But still, I have not yet started these other medical images, say, for example, ultrasound, SPECT, and PET. Okay, and recently I have been working with this X-ray images and CT images for the COVID-19 diagnosis. Okay, so this is what my research group, they are working in the biomedical imaging laboratory. And so now we're getting into the fundus imaging modality in the today lecture. Okay, so the retinal fundus image or the retinal fundus imaging. Okay, so what is this? So I think we know the retina. Okay, so normally retina is the part of our human eye which is located at the back side of our human eye, right? And what is fundus? Okay, then image, as we know, imaging, that we know. But what is fundus? Okay, that I will tell you why the name it is called fundus. Let's like for the better understanding of the audience. So let me start from the scratch. So how we can get the clear idea about fundus imaging. So for that, we need to recollect the anatomy of our eye, the human eye. So you can see here the anatomy of the human eye here, and we know the whole structure of this retina. And as you can see here, this is the front side of our eye, and the retina is located, is almost the back side of our human eye. You can see here, it is just almost back side of the eye. Okay, and here this is the very closest view of the retina, human retina. So your retina is here, and you can see here, this is the very closest view of the retina. And in general, the retina is consist of three major parts. One is the macula. This is the center part of the retina, and you can see here it is almost dark reddish in color. And the another major part of the retina is that you can see here like some bright part, you can see light yellowish bright part, which is this is called optic nerve head or optic disc. Okay, both names are same, optic nerve head or optic disc. And the outer part, the light background part is actually optic disc, and the inner bright part is called optic cup. Okay, optic cup. And after this, you can see a lot of vessels. It is just going towards this like retinal image. So basically, we call it as blood vessels. So this is called blood vessels. So why I am just highlighting this biological name of this particular retina, because this is very, very essential and very, very important for the better understanding of the retinal image analysis. So if you don't know these kind of biological terms, then it is very hard to understand the research perspective. So that's why as a teacher, I am just highlighting all this biological name. Okay, so it's very simple. The retina is consist of three major part. One is macula, then another one is optic disc, then another one is the blood vessels. Okay, so these are all the main parts of the retina. Okay, now coming to the point, you can see here in this particular image. So the retina is located almost the back side of the eye, right? Okay. So how we can acquire, how we can capture this retinal image? Okay. So like, is it possible to capture this retinal image with our conventional camera? No, it is not possible. So the conventional camera, it can capture only the front page, like the front side of our eye. But the conventional camera, they don't have any facility, to capture the retinal image because it is almost back side of the eye. So we need the specialized hardware, or we need some specialized camera, some customized camera to capture the retinal image. Okay, so to acquire this retinal image, so we have to use this camera, which is called fundus camera. Okay, so this fundus camera is going to help to acquire the retinal image. Let's say this is a very specialized camera. Normally it will be available in all the eye hospital and all the ophthalmological department of any hospital. Okay, so normally the study of eye, we call it as ophthalmology, and the eye doctor, we call it as ophthalmologist. Okay, so these are all the names that we have to learn. And you can see here, and this fundus camera, this is one of the ophthalmal scope. Normally it will help to acquire the our retinal image. So how this the fundus camera is working? So we have some special working principle here. Say for example, I can show you. You can see here, so how this typical fundus camera is working. So normally, the fundus camera, like it will be operated by the trained radiologist or the trained ophthalmologist, and they will be sitting in front of the monitor of this particular camera, and the patient, those who are going to acquire the retinal image, these will be sitting in the opposite side of the camera. And normally they will maintain some distance, based on the focal length, what is focal length, and so those who are know this image processing perspective, this, so that we have to maintain the distance. And you can see here, and in the camera, so we have the monitor, the screen to acquire the image. And what they will do, the doctors, so they will be penetrate the light source to the eye, Then we know that our eye is having the lens, So what this lens they will do, so the lens, they will attract the light wave, and it will just passing to the whole eye. Then it will reflect to the lenses. Then while the reflection, so we have the condensing lens inbuilt in this fundus camera, so that will be capture the whole part of the retina. Okay, so in that way the fundus camera is working. So if you want to more interest how this fundus camera is working, just you can get some YouTube videos, and lot of YouTube videos are available. So they will be help you to understand how this specialized fundus camera is working. Okay, I'm not going to spend more time on that, just I'm highlighting it. So here, so in that way the fundus camera is working. And once the camera, like the image is acquired by the ophthalmologist, then it will be stored into the computer. Then the computer, then we have the specialized tools to crop the unwanted portion. Then they will be capturing the retinal images. Okay, so this is basically fundus camera. It is working. So in that way, so we can came to know the retinal fundus image. That means that retina is the part of the eye, and the fundus is the camera name. Okay, and a lot of companies, it is manufacturing this camera, different camera, Fundus cameras are available. And one company is the TRC, it's very famous for manufacturing this Fundus camera. And we have the Robert Bosch Fundus camera. A lot of cameras are available, and that you can find in all these kind of high hospitals. Okay, so I think now you are clear what is retinal fundus image. Okay, fine. So here, what I am going to highlight. So what are the applications of this particular fundus image? So why we are acquiring the fundus image? Okay, so basically, suppose if you have any problem in the eye, in the human eye, so basically we have to consult to the eye doctors. Okay, so in that way, suppose if you have any problem in the eye, then there are two kind of preliminary screening they will do in the eye hospital. One is the visual activity test. Okay, so normally if you have any long sight or short sight or any visionary problem, so if you go to hospital, then you can find some some light source later, they will be placed in the hospital. Let's say they will ask to close your one eye, and they can ask to find or recognize the letter which is looking in the opposite side. In other way, they will ask to close the other eye, then they will ask him to visualize the letter. So based on that, so the doctors or the technicians, they will understand what is the problem in your eye. Okay, that is a preliminary test, that is called visual activity test. Then if you have any vision problem, suppose if you are not able to identify the letter, and they will take into the other kind of examination, that is called ophthalmoscopy examination. Ophthalmoscopy. So basically this is that ophthalmoscopy will be taken by the fundus photography. Okay, so they will take the fundus image, your retinal fundus image. So based on this fundus image, so the doctors, they can conclude what kind of problem you have, and then what kind of disease you have, okay, in the eye. Okay, so based on that, so they will suggest for the further treatment. So in that way, the fundus images is going to help for a lot of applications. Say for example, identifying the glaucoma disease, and identifying the age-related macular degeneration. This is one kind of eye disease, and also it will help to find other diseases. Say for example, diabetic retinopathy and retinal neoplasm. So a lot of diseases are there. So in very simple and short, so the fundus photography is going to help to identify the eye diseases. Okay, basically, and you can see here a lot of eye diseases which I'm highlighting in this particular slide. You can see more interestingly, based on the literature, there are 62 different kind of eye diseases are reported for human. Just imagine how many diseases. 62 different diseases are available, right? And I just listed some of the very dangerous eye diseases here, and out of which I'm just highlighted some of the diseases in red. So in the field of ophthalmology, so they will say these are all the degenerative diseases. Say for example, the first one is that I'm highlighted age-related macular degeneration. This is simply, they call it as AMD. And normally this disease will affect the elderly people, those who are age more than 50 years. They will be getting very hard to see the vision. So in those age-related macular, this disease will come, age-related macular degeneration. And another disease is the common disease for all human. It is called cataract, right? And the cataract, the white color particle that will be generated in the upper side of the lens, so it is called cataract. This is also very dangerous disease that we have to cure. And also we have very dangerous disease is called diabetic eye disease. This is called, we call it as diabetic retinopathy. And this particular disease that will be affected for the diabetes mellitus people, the diabetes patients. And another disease is called retinitis pigmentosa. And actually this is also one of the dangerous disease. And this disease will come from the transformation of the gene. If your parents is having this kind of disease, then the child is also having this kind of disease. So it is called retinitis pigmentosa. And also we have the another dangerous disease is called glaucoma. Okay, glaucoma. So normally this kind of disease that will be affect for all these IT employees because they have lot of work pressure, and they will be working more than 12 hours per day, and they are continuously looking to the computer monitor. Then their eye, they will be under pressure. Then once if keep on this pressure is continuing, then they will affect these kind of diseases is called glaucoma. Nowadays, teachers, we are also going to affect these kind of diseases because we are spending more amount of time with computer monitor and the mobile laptop, blah blah blah. Like because of this corona effect, every time we are delivering this online lecture, so of course we have to take care of our eyes. Otherwise, it will lead to the glaucoma disease. Okay, and these are all some of the eye diseases, and I am most working in some of the diseases. It is very hard to work with all diseases because 62 different diseases are there. And recently I have started working in this particular disease is called retinal detachment. Okay, I think the madam told the project which is recently got in the month of October 2020, the retinal detachment screening through the deep learning. Okay, some other eye diseases are also there. So you can start working on some these kind of diseases. And the next part, so I'm just going to highlight how these kind of eye diseases can have the changes from the normal vision. Okay, so what kind of impact will come to this particular diseases? You can say here, first we'll talk about this cataract. You can see here, this is the cataract. Normally in the eye lens that will form the white bubbles. Okay, so this is the symptom, the first symptoms of the cataract disease. So if you have the cataract, and what happens is that, and if you have the normal vision like this, and once if it is cataract is there, then your vision will be blurred. Okay, like so this is the symptom of this cataract disease. And the another disease is very common for the elderly people. It's called age-related macular degeneration. Simply we call it as AMD. So this particular disease, so that will affect the macula of the retinal image. You know what is macula that I highlighted? The macula is located the center portion of the retina. So in that way, this is the AMD. It will affect the center part of the retina. Okay, and the background you can able to see. Okay, it will affect to the macula part. That is why the name is called macular. It is normally it will affect for the elderly people more than 50 years. That's why the name they have framed age-related macular degeneration. Okay, and that's why the elderly people, like say our grandma or grandfather, they will be very hard to find the vision. So normally, if you want to recognize, so they will use their hand to identify it because their center vision they will gone. Okay, so and this way you can find the difference between the normal and the AMD. Vision difference, and you can see here if have this AMD and our retinal image, this fundus image, they will have some abnormal symptoms in this inside these images. Okay, so this is called basically the age-related macular degeneration. And you can see, I want to highlight one the video. So how the age-related macular degeneration that will be affect by the elderly people. So here I have an animated video. You can see here. Okay.
Sir, how to create the Google Forms?
I have one lecture, so
Oh,
yeah. Okay, so you can find the impact of this age-related macular degeneration. So normally it will affect the center part of the macula. Okay. The next is that another very dangerous disease is that glaucoma. You can see here the difference between the MD and the glaucoma. That so the glaucoma disease, you can able to see the center vision, but the whole background vision will gone. Okay, so that is the impact of this glaucoma disease, and you can able to see the difference of normal and the glaucoma vision. And this is the respective fundus image of glaucoma. You can see here the whole background, it will be blocked. You can see here. Okay. And the another disease which is called retinitis pigmentosa. Normally this disease, it will come for the gene transformation from the parents to the child. So it is the most dangerous disease because the whole background, it will be affected. Okay, you can't able to recognize the vision. Okay, and this is very dangerous disease, and also a lot of people are doing research in this. And this is like it is one of the very dangerous eye disease, and almost this is one of the world leading eye diseases, the vision loss disease in the world. Okay, diabetic retinopathy, because more people, they will affect this disease like diabetes. We can say diabetes mellitus, and if the people or the person is having the diabetes, then they have a more chance to affect this disease, diabetic retinopathy. Okay, so what the doctors are suggesting, if you have the diabetes, then you have to go for the hospital frequently, at least 6 months once, to screen your eye. Okay, otherwise it will lead to the diabetic retinopathy disease. Okay, and of course this is one of the world largest vision loss disease, right? Diabetic retinopathy. Then it will affect the whole part of their eye. Okay, it will not like differentiate whether it can be a foreground or it may be a background or something else. It will whole part to be affected. Okay, so this is a major like impact of the diabetic retinopathy disease, and you can see here the glaucoma and diabetic retinopathy. These two are the very very dangerous disease for Indians. Why I'm telling? Because as we know, the universal statement, India is the diabetes world. So most of the Indians, we are affecting by this particular disease, diabetic retinopathy. And also, India is one of the IT hub, and also not only India but also the other country, but especially in the Indian scenario, and most of the people we are depends on this IT culture, and of course we are getting these glaucoma diseases everywhere. Okay, so in the past 10 years, you can just classify before 10 years and after 10 years. So recently, a lot of high hospitals are coming. Why? What is the reason? Because most of the people, they are affected by their vision. That's why they need of urgent necessity of the hospitals. So that's why the new eye hospitals are coming in all metro cities. Okay, so this is the whole biological background of this particular today talk. So once if you know these kind of biological background, then it is very easy to understand the research perspective or the research scenario. Okay, and yeah, so you can see here this particular slide. So I'm just going to highlight the diabetic retinopathy disease, because this is very dangerous disease for the most of the Indians. And so in that way, you can see here in diabetic retin, the difference between the normal eye and the diabetic eye. So in the normal eye, you can able to see only the general retinal parts are there. Say for example, retina, macula, and optic disc. Okay, and you can see the diabetic eye. Other than this retinal part, we have n number of the unnecessary like features are there. The other part, other than this retinal part, we have n number of features are there here in the diabetic eye. In the diabetic eye, you can see here some of the retinal features are, we can say here, aneurysm. So generally we call it as microaneurysms, this feature. And once the microaneurysm is getting enlarged, then it will lead to the hemorrhages and also the cotton wool spots and exudates. So many abnormal features it will generate from the eye. And also some abnormal blood vessels. That means that normally the blood vessels are continuous in nature. So if you have the diabetic retinopathy, then what happens is that, so the continuous vessels, it will break somewhere due to the impact of the diabetes. Okay, so that is also one kind of abnormal feature in the diabetic retinopathy. Okay, so these are all like some of the abnormal features of this particular retinal images. Okay, so now the research is coming here, like say, so these works basically are doctors, the eye doctors, the ophthalmologist, right? How as a technologist, how as an engineer, we can able to help, we can able to do the contribution from this retinal image perspective. So the idea is that you can see here the developing countries like India. So we have very less number of eye doctors in the country, but our population is too much. Our population is more, but the thing is that the number of eye doctors and eye hospitals are very less in the country. Okay, so there is some need, and there is the urgent need in the technological development. Okay, say for example, what happens is that in the diabetic patients, so they have to go for the periodic eye screening at least 6 months once. And so in that case, so they have to take the consultation from the hospital, and they have to wait for getting the consultation, and also they have to fees, and a lot of consultation fees and a lot of things are there, and even the elderly people now in this pandemic situations, it is going to or visiting the hospital, it is quite challenge. So in that way, as a technologist, so we can play a very, very important role here. So suppose if we have the retinal image, then we can able to develop, or we can able to develop some computer-aided diagnosis model, or we can able to segment those abnormal retinal features from the eye. Okay, so from the analysis, so we can conclude whether the person is having diabetic retinopathy or not. So if they have diabetic retinopathy, they can go to hospital. Otherwise, they can stay and they can save their money and time, effort, everything. Okay, so in that way, as a researcher, as an engineer, we can able to contribute a lot of things in this area, in terms of the diabetic retinopathy perspective. Okay, so not only for this diabetic retinopathy perspective, but also in other kind of diseases, say for example, glaucoma and AMD and retinitis pigmentosa and other kind of diseases. But for the today talk, I'm just highlighted only the diabetic retinopathy because it is one of the most dangerous eye disease than others. Okay, so in terms of the international disease severity scale of diabetic retinopathy, normally this diabetic retinopathy is divided into two major types. One is NPDR, which is called non-proliferative diabetic retinopathy, and another one is the proliferative diabetic retinopathy. So in further, the non-proliferative retinopathy, it is divided into mild, moderate, and severe stages. So here, how the doctors, they can able to see, they can able to classify the stages of non-proliferative diabetic retinopathy. It is based on the features available in the retinal image. Say for example, if there is no feature and there is no retinopathy, and suppose if they have the microaneurysms inside the retina, then they can say the mild non-proliferative diabetic retinopathy. That means that the microaneurysm, it is the first clinical symptoms of diabetic retinopathy. Normally, it will be a very small particle and small reddish particle that will be created in the like in the retina. And if you have microaneurysm, then it will come under the mild non-proliferative. And if not, then we have to check the other retinal features, let's say exudate or cardinal spots or hemorrhages and further. Okay, but here what happens is that if you have microaneurysms, then you can able to judge it is in the mild. Otherwise, it is based on the feature, then you can classify whether it can be a moderate or severe or whatever it is, or proliferative. Okay, so here the technologist as a scientist or a researcher, you can able to contribute a lot of research problem here. Say for example, if have the fundus image, then you can able to propose this, any segmentation algorithm or any localization algorithm, and to extract the this to segment these microaneurysms or any other retinal abnormal features. Okay, so based on that, we can able to classify the stages of the diabetic retinopathy. Okay, so in this small retinal fundus image, like infinite number of problems are there, problem statements are there. So we have to select the correct problem statement, then we can able to do a lot of research in this area. Okay, and you can see here, and in terms of the retinal fundus image, the effect of diabetic retinopathy here. You can see here, the number 1 is normally we call it as early non-proliferative, and number 2 and 3 and mild and moderate advanced retinopathy. And if you go for the 4th stage, it is the proliferative retinopathy. Then after this, that person that will lose their vision. Okay, so this is the common effect of diabetic retinopathy. And as far as the disease severity scale and the hospital, if the person is having like 1, 2, 3, then the doctors, they have the laser treatment and they will treat and they will save the vision. If it is not treated in the 3rd, then it is very hard to restore the vision of the person. Okay, so this is the major impact of this diabetic retinopathy. Okay, so as of now, so what we learned from this in the first 1 hour, so we have learned the whole biological information of the retina, and also we have learned these kind of what are the eye diseases that are available, then what are the impact of these eye diseases, and even in specific, so what is the impact of this diabetic retinopathy disease. Okay, so up to now, so we can get into the research perspective. Say for example, if you want to do any kind of contributions or any type of research, so obviously in terms of image processing perspective or in terms of medical imaging perspective, so we have to play more with the proposing of the new algorithms, because as a scientist, as the engineers, as the technologists, either you can develop the new technology or you can propose some new algorithm to the image processing domain. Okay, so in that way we can contribute a lot in this particular domain. Okay, so normally in terms of diabetic retinopathy perspective, the computer-aided diagnosis of diabetic retinopathy is majorly, it will do in many ways. One is the conventional image processing perspective, and we can do with the other machine learning perspective, and of course we can do deep learning perspective also. Okay, so first what we can do, as the technologies, if you talk about this conventional image processing techniques for the computer-aided diagnosis of diabetic retinopathy, so fundamentally, so we have to do a lot of conventional image processing steps. Say for example, so we need to create the database, okay, the retinal fundus image database. So this particular database, so we can the retinal image, we can the two way we can collect it. One way, many number of retinal online data set is available. Okay, that data set name and the link I will show you the end of this particular presentations. And otherwise, and if you have any good contacts in your nearby eye hospital, then you can collect some real-time retinal images from the hospital for the research purpose. Okay, so in both the way you can do these retinal fundus image data collection. Okay, and here what happens is that, and here for doing the research, and we have a lot of database which is available online. Okay, that link I will show you at the end of the presentation. And if you have the database, then what we have to do as an image processing researcher, so you have to play with more number of these kind of fundamental image processing steps. Say for example, the pre-processing and segmentation, feature extraction, and feature selection, then classifications, and those kind of things. Okay, so that we have to identify, then we have to propose in the novel thing in any one of the steps. Either it can be a pre-processing or segmentation or feature extraction or the classifications. Okay, any one part or any one step that we have to contribute in the unique way. Okay, so in that way, so we can do a lot of research in this area. Okay, in terms of the conventional image processing perspective. Okay, so here from this, so I can highlight some of the conventional image processing works which we have carried out and which we are working on it. Okay, so recently we have did the microaneurysms localization in retinal fundus images. Okay, as you know, what is microaneurysms? Because the microaneurysm is nothing but it's a small features, and of course it is the first clinical symptoms of diabetic retinopathy. And you can see here, so these microaneurysms are marked in this particular images. Okay, and why we are localizing these microaneurysms? Because it is the first clinical symptoms of diabetic retinopathy. Yeah, the small part of an abnormal feature it will come. So if you can able to localize, or if you are able to segment these microaneurysms in the retinal fundus image, then we can judge, we can conclude the this early detection of diabetic retinopathy disease. So that is the objective of this particular work. And of course in this work, so we have followed the conventional image processing steps, and we have collected more number of retinal images from both the way, from the online database and as well as the hospitals. And we have performed the pre-processing steps like masking and other kind of pre-processing. And here we have proposed the segmentation algorithm. And once if you segment it, the unwanted portions are the required features, then we have to extract the correct features. Then we'll have to go for the microaneurysms localization. So this is the whole workflow of this work which we have carried out. And so you can see here some of the step-by-step output of this particular work. And you can see this is the input image which we have just applying for the testing purpose of this particular work. And it will able to recognize the number of microaneurysms which is present in this particular eye. So if the number of microaneurysms are more, of course it is very dangerous. So that particular people or that particular person, they have to go for the consultation of the eye doctors. If the number of microaneurysms are very less than the treatment that can be changed accordingly. So in that way, so this kind of localization algorithm can help you to predict the diabetic retinopathy disease in the early stage itself. Okay, and these are all some of the other images that we have utilized for the testing of this work. And so these are all the data sets. So we have used like no number of retinal data sets which is available in online. So namely drive, stare, and direct DB0. So these are the online data set which we have. And of course, this particular work, this algorithm, this workflow, it will be outperformed well in all three kind of data sets. Okay, and which is available. So if you want to this like interested, you can go through this work. So it will be available in online. Okay, and I want to highlight one more like conventional image processing work with this retinal fundus images, the retinal blood vessel segmentation using expected maximization algorithm. So this algorithm we have proposed recently, the expected maximization algorithm we have derived for segmentation purpose. Say, for example, you can see here, this is one of the typical retinal fundus image, the normal image. If you apply this particular algorithm, you will get the clear segmentation of the retinal blood vessels in the from the fundus image. And you can see here, if the blood vessels are in continuous nature, and the eye is in normal condition, and if you have any breakage, and if you have any discontinuity in this particular vessel, then of course they have to go for the treatment. So in that way, so this particular work can help to predict the eye diseases. Either it can be a diabetic retinopathy or it can be a glaucoma. Basically, it will help to find the abnormality of the human eye. Okay, so you can see here, this is the workflow of this particular work. So you can see here this particular fundus image that we have to divide it into two components. One is the grayscale and another one is the green component extraction. And in the green component extraction, so we have to play with all conventional image pre-processing steps, and say, for example, intensity inversion and histogram equalization and morphological image processing. So these kind of conventional processing we have to do. And the grayscale perspective, so we have to go for this optic disc detection, border removal, and noise removal. So all these kind of grace that we have to do in the grayscale perspective. Then finally we will club and we'll apply this expected maximization. Then we get the segmented blood vessels, okay, from the retinal fundus image. And you can see this is some of the step-by-step output. Okay, and this is the input image which have applied this particular algorithm. Then it will extract the whole blood vessels from the images. And you can see here some other retinal segmented blood vessels images also. I just highlighted in this slide. From the slide and from the images, you can able to find which one is normal image and which one is the abnormal image. You can easily find out. You can see here the first image, so it is a normal image. There is no breakage in this blood vessel. You can see the second image. You can able to find a lot of discontinuities there. And this particular person, they have to go for the consultation. Okay, so in that way, so we can suggest some of the ideas. So those who really want to go for their treatment through their automated this kind of methodologies. Okay, and up to this, I'm just highlighted only the two works, but I have been worked with a lot of works in this, and especially this kind of segmentation and feature extraction of the retinal image parts. Not only for this blood vessels and microaneurysms, I have been contributed a lot for other retinal parts, say for example exudates and optic disc and optic cup, a lot of things which I have done. And all these features having their own speciality. like it depends on the diseases. Say for example, if you want to say to screen, or if you want to diagnose this glaucoma disease, then we have to go for the optic disc and optic cup segmentation. Okay, so every retinal part segmentation, they have their own specialty to identify the diseases. Okay, and that way, so I'm just in that way, so I'm highlighted only these two works here. But if you want to learn further, you can just check my publications. And so in that way, what we have to do, we can do a lot of conventional image processing algorithm. And the another way, the another dimension in terms of research. So now the people are everywhere, they are working with the machine learning algorithm and the deep learning algorithm. Okay, so in that way, so we can work with computer aided diagnosis of diabetic retinopathy using deep learning. So as you know, the conventional image processing, that all these features that we have to do with our own algorithm. But here what happens is that the same kind of diagnosis, you can go with the deep learning algorithm or the deep learning architecture. And it is quite simple because we no need to identify, no need to contribute any new algorithm here. The only thing is that, so you need to collect the large amount of data. We need to collect more amount of retinal fundus data set, then only the deep learning algorithm will outperform well. Otherwise, the efficiency of this deep learning architecture, it will be not up to the mark, because all the deep learning algorithms are data hungry network, so they need large amount of data basically. Okay, so how these deep learning algorithms are working, so it's a basic perspective. So you need large amount of data set here, and what you have to do, so you have to train the deep learning network. So once the network is trained, then you can go for the testing. So once the trained network is available, then you can test the network, either it can be any kind of retinal images, whether it can be a normal images or abnormal images, or it may be a disease specific. It may be a diabetic retinopathy, or it may be a AMD, or it may be a glaucoma, or anything. Okay, then you can test the particular diseases or the diseases stages. It is depends. So how much amount of data set you are going to train. Okay, and you can see here, this is the general workflow of this diagnosis of diabetic retinopathy. And here I want to highlight, so how this deep learning algorithms are varying from the other artificial intelligence framework. So normally, as we know, the engineers, in artificial intelligence, that we came from that machine learning. Then from the machine learning, we are taking the another technology called deep learning. But the major difference between the machine learning and deep learning is that in machine learning, so we have to extract the feature, manually. Okay, then we have to go for the classification. But in deep learning, so the feature extraction and classifications, so the both are doing in the same step. Okay, so we no need to extract the feature. Okay, the deep neural network itself, so they will extract the feature from the database. And in machine learning, so we have to define the feature, what feature we have to take from the images. Okay, so in that way, so we have the lot of false negative. So sometimes what we have to do, what happens, so we will miss some features, but if you go for the deep neural network, and there is no misclassification, like that can be reduced the false negative. So the network itself, they will collect all the features from the database. Okay, so in that way, the deep learning network, that will be help to the retinal imaging perspective. So how this retinal, the deep learnings are working, the deep learning architectures are working with brain inspired learning. The brain inspired learning, it is nothing but it is a multi-layered functions. So so that we need massive amount of data, and in that way this particular deep learning, it will be outperform well in retinal fundus images and as well as the other medical processing applications. Okay, so now from this introduction of this particular retinal say deep learning, so we'll getting into the a very important deep learning algorithm is called convolutional neural network. So I think many of them you heard about it, and this convolutional neural network, the CNN network, is performing very well in all kind of applications. And you can see here this convolutional neural network. It is consist of convolutional layer and the polling layer. And this convolutional and polling layer, normally we call it as in the neural network framework, it is a hidden layer. And the fully connected and the softmax layer, it is a classification layer. So this layer architecture, so we have to design based on our problem, based on our applications. Okay, so how many number of convolutional layers we require, and how many number of polling layers we require, and the fully connected layer and the softmax function that we have to select based on the number of classification. Is, for example, if it is a binary classification, then you can select the two fully connected layer. Otherwise, if it is 3 class problem, then you can accordingly you can select the fully connected layer. Then you can select the softmax. Then accordingly, the deep neural network then able to classify the particular diseases. Okay, and here the basic operations that we have performed in this deep neural network with the help of this depth process and the stride process, that is based on the the number of filter that we have been selected. And in the hidden layer, normally in the convolutional neural network, so we have to perform two basic operations. One is the convolutional operation and another one is the polling operation. So in the convolutional layer, what we have to do, so we have to define the convolutional filter. So either it can be a 2x2 filter or 3x3 filter or any kind of filter, and that we have to match with our input image. Then we have to perform the convolution operations. Then in that way, it is based on the number of convolutional layer. So the features can be extracted from the data set. Okay, that feature normally we call it as in CNN framework convolved features. Okay, in other way, in the hidden layer of CNN, we have to perform the polling operations. Okay, so how the polling operations can be performed in the CNN network? Normally, it will be performed based on the a polling filter. So, for example, if it is 2x2 filter, then what we have to do? So we have to match with this feature map with 2x2 filter. Let's say here the first 2x2 6 4 5 4 is there. So if in two way we can perform this polling operation. Either it can be a max polling operation or it may be a minimum polling operation. So these two operations that we have to select based on the application. Say for example, if you want the high resolution images, then you have to go for the max polling. And if you want the low resolution or the low contrast, then you have to go for the minimum polling operation. And if polling is performed in this 2x2, so here we have 6 4 5 4 feature. So what will be the maximum pixel here? The 6 is the maximum. So that's why the maximum polling that will be taken as 6. If it is minimum, then it will take 4. So in that way, the polling operations can be done in this CNN network. Okay, so from this basic understanding about the deep learning and the CNN network, now we'll getting into the deep learning, traditional machine learning. So as we know, in the traditional machine learning algorithm, how they will work. So here, suppose if you are applying this retinal fundus image for the classification purpose or the diagnosis purpose, So we have to define the features first. Then once the feature is like defined, then we have list the feature, then it will feed into the neural network. So in this network, it will classify in which category. So this is the normal traditional pattern recognition or machine learning that we have been used. But well, going for the deep learning, so we can directly replace this feature extraction step. So that deep network itself, they will do the feature extraction and classification. Let's say how this deep learning is working. Let's say, for example, if we have the fundus image, so then the deep learning architecture, there are 3 different levels of feature that will be extracting. One is the low level feature, and another one is the mid level feature, and another one is the high level feature. Okay, once if all these 3 levels of feature has been done, then automatically this deep neural network that can be trained. So once the network is trained, then you can test any number of images under this category. So the trained deep neural network, they can automatically suggest you which category of this particular images. Okay, so in that way, the deep learning networks are outperforming well in the retinal image analysis. Okay, and here in the retinal image analysis, so the representation of the depth process, it can be done in this way. Say for example, so you have like more number of data sets, images for train the network. And in the deep learning, so normally in the hidden layer, so we have to define the layer based on the low level, mid level, or high level. So if you want all these 3 levels, then accordingly you have to select the hidden layer. Otherwise, if you want only one level of feature, accordingly you can select the hidden layer. Okay, then it will be getting the corresponding output. Okay, in that way, the depth process, the deep learning process can represent. Okay, so here I want to give the demo of a very simple the convolutional neural network. So how the convolutional neural network can be trained to classify the abnormality of the retinal image. So that I want to give the demonstration. So I'm just skipping this presentation. Then I will getting into the topic. Say for example, the MATLAB that I want to show. Okay, can you able to see my MATLAB screen from there? Your end?
No, sir.
No. Okay.
Was
Just
visible a minute back.
No, sir. No, sir.
yeah. Just a moment. I think now it is visible.
Yes, sir. It's visible.
Yeah. Thank you. Okay. So, so here what I'm going to do here is that because I'm working with tech staff in my office presently, so I don't have workstation here now. So in my office, so I'm just going to highlight, a very simple example of this how we can perform the convolutional neural network for the diagnosis of the retinal image. And before that, so I want to highlight, very basic things before getting into the MATLAB program. Let's say here, so I want to show you my desktop. Okay, is it visible? My screen is visible?
Yes, sir.
Yeah. Okay. Thank you. You can see here in my desktop. So I have one folder. You can see here.
Sir,
Fundus.
can you please increase the font size? Just zoom in.
Yeah. Yeah. Sure. 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 Otherwise, view large icon. Yeah. I think maybe visible. I hope so. You can see here. Say. We know if we like before getting into any CNN architecture or any deep learning architecture, so we need work with the data set. So that is very, very important. So what I did here in my desktop, I have one folder that is called Fundus Deep Learning. I'm just opening this one. So in the Fundus Deep Learning, I have one folder that is called Dataset 1. Okay, Dataset 1. So in this dataset, I have two folders. The name of this folder is number 1. You can say the large icon. So number 1 and number 2. Okay, let's see. Open number 1. What is it is available? You can see here number 1. I have stored the retinal fundus image. You can see here. This is one image I have stored, and I have stored the another image. Okay. While looking itself, you can able to like differentiate. This is the normal image. Okay, here there is no any abnormal symptoms are available. Okay, and the same way, when I'll go for the data set 2, I have stored only 2 images. You can say here, this is one of the abnormal image. You can see here, lot of abnormality you can find. You can see here, macula is affected, and here microaneurysms are there. And you can check the other feature. You can see the whole microaneurysms.
Excuse me, sir.
Yeah.
We are still seeing only your Explorer. We cannot see the image.
Yes, ma'am.
Not see the image. Okay.
Yes, the images are not visible.
Okay, okay. One second. Can you see it now?
Yes, sir.
Yeah.
Yes.
See here, I am just storing some normal and abnormal images in my database. Okay. And you can see here, this is the typical abnormal images, because here a lot of like microaneurysm and the exudates are present. Okay. So in that way, so what I have here, I have saved one data set that namely fundus imaging in my desktop, and here I have saved only 2 images in normal case and abnormal case. So why I have been taken very few images, because while training the network it will take more time. Okay, so for running more number of images, we need the workstation with GPU. Okay, then only we can, like, the computational time will be very less. Otherwise, the single desktop, it will take long computational time. So for avoiding those circumstances, so I have been used only 2 images. Okay, only 2 images here. Okay, now we can go for the programming part. So here I can share you my MATLAB screen. Okay, so yeah, so you can see here, and this is my the deep learning program. So here I have typed everything, because I will explain to you for the better understanding, because if you type the program, then it will take a lot of time. And here, what I'm doing here, you can see here, say for example, I have the database in my desktop. So what I'm just defining here in the programming, MATLAB root and C users NIT as this desktop I have. So in the desktop, I have a path on fundus deep learning and dataset 1. Okay, so this is we have, which I have in my system. So in my system that I have two folder, number 1, number 2, that will automatically the data will read. Then once the data will read, then it will be saved in the train data variable. So okay, the data will automatically saved in the train data. Okay, so now after training this data, then what I have to do, I have to go for the like convolutional neural network. So that I have to design a convolutional neural network architecture. So we know the CNN architecture that we have to define the number of layers, the number of convolutional layer, like a number of max pooling layer that we have to define. And also we have to define the fully connected layer and the softmax layer for classification purpose. Okay, so here what I have designed very less number of layer I have selected. So I have been designed because of the computational time issue. And you can see here this whole input image layer that will be the size of 366 cross 448 into 3. And I'm just defining this convolutional layer. So how to define the convolutional layer in MATLAB? So we have to use the convolution 2D layer function. Okay, in all MATLAB 2018B version, so these functions are default, it is available. And if you have MATLAB 2020B version, the deep learning toolbox itself, it is available in the like MATLAB. So that you can, I can suggest you to work with all this deep learning architecture. Then you will get all these drag and drop options is also available in 20B version. So here I'm just using 18B version. So I'm just manually writing all this, like a CNN architecture. So I have been used the convolutional layer and the max pooling layer. So for convolution layer, I have to use the activation function. That will be I'm using Rayleigh layer. And here I have used the same. And once if it is defined this hidden layer, then I have to use, I have to classify the network. No? So for classification, I have to go for fully connected layer. But the fully connected layer, so here in my database, I have been used only the binary classification. So what I'm going to do here is that I have been saving only the normal images and abnormal retinal images. Okay, so in that way, I'm selected only the fully connected layer 2, and the softmax layer, of course, we have to select. Then automatically it will classify. Okay, so once the network architecture is designed, then we have to go for the training options of this CNN network. You can see here the training options. So that hyperparameter which I have selected for this network is that, and it is the algorithm, training algorithm, SGTM, and the number of epoch. So 15 I have selected, and the initial learning rate I have been selected 0.001. So these are all the hyperparameters. So normally we have to select before training the network. So once if it is selected this hyperparameter or the training options of the CNN network, then you can train the data, network data. And once it is trained, then it will save into the convolution net. Okay, so here after selecting this, and we have to like go for the classification. So what kind of classification which we have to perform? So we have to classify the network this convolution net with the images. Then what kind of images that we have to classify? Either it can be a normal one or it may be a abnormal one. So these are all the parameter which we are going to like classify. So in between, actually, this program I'm just putting on a comment. If you enable this, because it will take long time. Say for example, this rest of the lines it will help for the plotting the ROC curve and the confusion matrix and other thing. So that will be not required initially for understanding purpose. So once this process has been done, then what you have to do? So we have to test
Excuse
the
me,
data.
sir. I'm so
Yeah.
sorry to interrupt, sir. Can the font size be zoomed a little? Or if you could
Okay.
just maximize the size of the editor.
Okay. Okay, I think
If you could just decrease the size of that current folder, automatic editor will be enlarged.
like this.
Yes, sir.
Is it okay?
No, actually, it didn't increase the font size anyway.
I think for increasing this editor window font size, we have to go for MATLAB settings actually.
Okay, okay.
And
So can you just do a control plus plus, then your screen size will increase. We'll be able to see.
I think the control plus size is, I think it is only applicable for screen, not for the software, I think. I think this we have to go for settings. Then only the font size will increase. So how to increase it? I just forgot. Okay, I think this is one way, and otherwise I can share the program, not an issue.
Okay, that would be okay. Right, maybe after the session.
Yeah,
can just
after the
understand
session,
things
I will share the program to the coordinator, Radhika madam. I think she may help you to share
Yes,
all
it is
these
Radhika, sir.
things. Yeah. So I think madam will,
Sure,
help
sure.
you to share, to share this program. Not a big
Okay,
issue.
that would be great.
Yeah. Okay. So now after like designing this network and the selection of this hyperparameter, and we have to test this network, right? Once it is trained. So for example, in my MATLAB directory, say suppose if I'm having image, you can see here this first image, say for example, test1.jpg, and this one this is the normal image. Say for example, if I'm testing the normal test1 image, then this program will classify it should be a normal image, right? And I'm just clubbed all testing and training in a simple program that will for the computational time. Otherwise, this running also it will take long time. And you can see here after defining all the issue, if you run this program, you can see here I'm just running it, and this is the image I want to test and train. You can see here I have selected 15 epoch. So the architecture is training now. Yeah, you can see here this network is trained. After this, the network itself, it is suggested is the normal image. It is the normal image. So in the same way, you can test any kind of images. Once the you can see here, this is the abnormal image. You can see here, and some features are there. So I'm just replacing with 1/2 here. If I'm running the same code, and you can see here, once the network is trained, and it is going to test now. Yeah, you can see here, this is the abnormal image. Okay. So here what I did, I have used only very few images because of the timing issue, computational timing issue. So in that way, what we can do, you can further extend this work. You can use more number of images, and also you can use some specific diseases. Either it can be a diabetic retinopathy, or it may be a glaucoma or AMD or anything. So for any disease prediction, you can select the data set accordingly. Then the architecture, you can do that. Then obviously you can easily diagnose any kind of diseases, okay, from your own idea. Okay, so this is the part which I want to highlight, but don't worry, I'm just share this program to you. So I think then you can run it from your side. This program is having all kind of fundamental information, how to generate ROC and computation, confusion matrix, and other kind of performance metrics which you have. I will share with you, not a big deal. And from this, so in that way, we can use this, the convolutional neural network for the computer aided diagnosis. Okay, and here, like from this perspective, so which I have carried out one work in this last year, which is the abnormality detection of retinal fundus images with the deep convolutional neural network. So I have been utilized this convolutional neural network, CNN architecture, and the unique part of this work is that, so we have the data augmentation part. Normally, for classifying the abnormality of retinal fundus images from the various sources. Say in online data set, the size and resolutions, that is something different. And if you are collecting the hospital images, the size will be different. So for matching these all the criteria, so we have did the data augmentation part. Then we have developed the CNN network, and the CNN network is performed well for the classification of the abnormality of the fundus images. Okay, this work which we have carried out, and of course this work was collaborated with our local hospital, the Silchar Medical College and Hospital, and Dr. Partha Pratim Roy is also part of this research work, and this is also available in the online, so you can check it out. And here the novel thing which we have did, you can see here, these are all the sample training images which we have been utilized for this architecture. So we have used IDRD dataset, the ROC dataset, and also of course we have used this our local dataset, the real-time images which will be collected from the local eye hospitals. And okay, so these are all the things. So as a technologist, as engineers, we can able to do in terms of the AI perspective for any disease prediction case. Okay. So as a researcher, so what are the common challenges so we have to face in the field of medical data analysis? That is very important, So if you want to do any deep learning architecture or in medical data analytics, we have to face a lot of challenges. Say, for example, the first one is the data. Okay, so we have to collect the data because our input is images. Say, if you want any real-time images from hospital, who will provide this image? Who will provide this data? It is quite challenging, because nobody having the time. The doctors, they don't have time. So that is one kind of challenges. And another challenges is that, like we have demonstrated the CNN network, and this is very simple network. But apart from this deep, simple CNN network, we have n number of pre-trained CNN network which is also available. Okay, that for the selection of model, that is also very quite challenging deep learning perspective. So once if you have enough data and if you are able to select the model, then the interpretation of the result is also very important, because in terms of medical perspective, always we need the doctor's help, to find out this, exact result. And also this, this model, it should be a human, friendly. So then only it can be used by the common people. Okay, so in that way, we have to face a lot of challenges in the field of medical domain while using the deep learning. So apart from this, we need large computational facility. That is very important. Even if you have the engineering and other kind of thing, so how many of them we have the GPU server in our laboratory, and how many of them having the workstation to work with deep learning architecture? Okay, that is also the quite challenge, for working these areas. Okay, so these are all like challenges while working with the deep learning. So if you address all these points, then it is very easy to work with this medical image analysis with deep learning. Okay, and you can see here for selection of model, you can see here you can use any pre-trained network which will be also available in publicly. So like CNN, we have AlexNet, we have GoogleNet, and we have BGG, and we have Inception, and we have ResNet and SequenceNet. So many pre-trained network is also available in the internet. So as a researcher, you can select any there's a pre-trained network for your applications, and also you can club with the one pre-trained network with the other pre-trained network. So you can develop the ensemble deep architecture. So that is also very famous in the research, in deep learning research. Okay, you can club with AlexNet with the GoogleNet or some other BGG. So in that way, you can able to design your own unique architecture, the ensemble architecture. Okay, in that way, so you can you can proceed better classification, better diagnosis in that. Okay, so this is also you can do that. And another point which I want to suggest to you all, like in terms of the AI perspective, or in especially in the deep learning perspective, and where we can do the novel idea, the novel thing in the deep architecture. So the only thing is that we can select the unique applications in one side, and another way you can do the data augmentation part. That is another kind of novelty you can do. Then another way, the novelty you can do in the work is the training algorithm, selection of the training procedure. Okay, and here I can suggest you some of the novel training methods in deep learning. So, for example, one is the transfer learning. That is very, a famous training algorithm in deep learning framework. And of course, the extreme learning, it is also very important training algorithm. And of course, the third one is the optimized learning. So the for a selection of the hyperparameter of the CNN network, you can use the optimization algorithm. Okay, instead of selecting the manual parameter, you can go for the optimization algorithm. Okay, so that is also one of the novel training method in that, because we have a lot of meta heuristic optimization algorithms are available that is proposed by many researchers. Say for example, particle swarm optimization, whale optimization. A lot of optimizations are algorithms are available. Ant colony optimization. Okay, in that way you can select some unique optimization algorithm for training the network. Okay, so recently I have been worked with all these novel training algorithm with X-ray images. As you can see here, recently I have been developed this technology is called eDiconet, for diagnosis of COVID-19 using deep convolutional neural network. So this particular architecture can able to classify whether it can be a normal, or it may be a pneumonia, or it may be a COVID-19. Okay, so here in this architecture, so I have been used this extreme learning machine classifier, okay, for train the deep neural network. Okay, and after this, I have been developed the another architecture is called OptCoNet, and here I have been used this optimization algorithm for selection of hyperparameter of the CNN network, and the optimization which I have been used for this architecture is Gray-Wolf optimizer. So the Gray-Wolf optimization algorithm initially proposed by the researcher Said Ali Mirjalili. He is the data scientist from Torrens University, Australia, and I have been collaborated this particular research with him, and as well as our local eye hospital, the Debakumar Chakrabarti, the radiologist in the Department of Radiology. And we have been proposed this particular architecture for efficient diagnosis of COVID-19, pneumonia, and normal. Okay, so these two architecture I have been developed for the X-ray images, and also I have been developed another architecture is called OptGyan, that is a generative adversarial network. So initially this particular architecture I have been developed for the CT images for the diagnosis of COVID-19 from normal images. Initially, the number of images we have very few in CT images in the month of March, April 2019. So in that way, like what we have to do, so we can use the generative adversarial network. This is the the another extended version of the deep learning algorithm. So initially, the GAN or the generative adversarial network architecture is proposed by the Google research scientist. Ian Goodfellow. So he has proposed this architecture. So the advantage of this particular architecture is that so you can generate more number of images from the generator. The discriminator, they will classify which one is real and which one is fake. And in that way, so I have been utilized this whale optimization algorithm again for optimizing the hyperparameter, which is proposed by the same scientist, Said Ali Mirjalili. And so here again, for training the network, we have used the ResNet 50 pre-trained network. And finally, this particular network is on classifying COVID-19, and either it can be a non-COVID-19. Okay, all these works are available in online. If you have interested, it's my pleasure to read this particular article. Then you will get a lot of information how to do the novel training algorithm, then how to design the novel architecture in the field of deep learning. Okay, so up to now, so I can conclude the today lecture. Say as a researcher, so I can suggest you a lot of key problems in between the presentation. And even though I am highlighting here, as if you want any medical imaging interest, you can work with the diagnosis of COVID-19 images, because this is a lot of research people are contributing here. And you can do that, and you can use lung segmentation of COVID-19 images. It's also the very important key research problem in the recent scenario. And of course, retinal images, it's also very interesting research domain. You can do for detection, classification, segmentation. The same way you can use for MRI and also the cancer. That is a evergreen research problem always. And recently, this last research problem is quite interesting in the field of medical image, because very few research groups are working in this. And we are also just recently started this work, like automatic translation of medical image to text. Okay, so if you have the medical image, so from the image, so they have to go for the text. Okay, so that automatic translation, it is also very important problem in the recent time. So you can also work with these kind of problems. So then with this, so I can conclude that today the presentations. So of course, the deep learning, so that can be used for n number of medical image analysis in perspective. Say for example, the quantitative imaging tools or computer aided detection or decision support tools or any diagnosis. So that way the deep learning is outperforming well in all type of medical imaging perspective. And the future of this medical imaging, so almost all the researchers, they are working with two-dimensional images, but now the things are advanced, so the people are started working with 3D and 4D images, because these are all very very good in terms of medical image analysis other than 2D. And of course, the future of medical imaging will be 3D and 4D, not in 2D. Okay. And so up to, and these are all some of the known things which you want to learn. So these are all the like retinal image data sets, which is publicly available online. Okay, so if you want to download any images, you please refer this paper, and this paper will have all these URL links, everything. So I will supply this presentation PowerPoint to the organizers, and you will read this particular paper. You will get all the websites where you want to download. Okay, a lot of data sets are available. And also, if you want to work with this X-ray images for COVID-19 diagnosis, so here also a lot of publicly available data sets are also available. And if you want the link, you can just refer my paper. You can type UpcoNet in Google. You will get the paper. So from the paper, you will get the reference where you can download all these images. Okay, then up to, I want to suggest you one publicly available tool for the image processing beginner. That is called the CVIP tool. It's called Computer Vision and Image Processing Tool. And the speciality of this tool is that, so it is a drag and drop tool. So you no need to write any programming. So like with the help of this tool, you can understand all the image processing fundamental, all like enhancement, segmentation, feature extraction, all kind of image processing fundamental. You can familiarize with this tool. So if you are interested, you can download and install, and you can just happy to work with this particular tool. And these are all the references which have been utilized for these presentations. And these are all the textbooks which have been learned. Of course, these are all AI and machine learning, deep learning textbooks. And finally, I'm just concluding this today's talk. So like the conclusion is that will belongs to the biomedical imaging group of this institute. So we are always welcome for any collaborative work with other researchers. And if you want to collaborate, you can feel free to write to my email, which is mentioned in the PowerPoint. And in other way, you can, like if you want to do PhD under my supervision or in other supervisions, so you can just feel free to write email. I will help you to, do the PhD in NIT Silchar. And normally in this institute, it is offering a PhD in two domains. One is the Group A and Group B. And Group A is the full-time PhD. So for full-time PhD, you need GATE score or the NET score. So if you have GATE NET score, then you will get the scholarship from the institute. So you will get the JR like scholarship 31,000 per month. So up to 5 years, the university will pay for you. Then you will do your research in the campus. Then so in that way, you will get a full-time PhD. And also the institute is offering another type of PhD called Group P. That is called in Group P, two categories there. One is a full-time, that is a non-scholarship. We can work from the institute. The institute will provide the basic infrastructure, but they will not provide the stipend. Okay, and also it is offering the part-time PhD. You can work anywhere in the country. Then you can get like the part-time. You can get the PhD from the institute. But for a part-time PhD, you have been work you have to be stay 1 semester in the institute for doing the coursework. So rest of the semester you can work anywhere in the country. So once if you are satisfying the like institute norms, then you will get the PhD degree. Okay, in that way, so the institute is offering a lot of PhD fellowship opportunity for the researchers. And also in my lab, I'm providing a lot of internship opportunities for the students like BTech or MTech or PhD students, like faculty also. And if you have interested, if any of the students, so you can write email to my, just write a text mail, then I will help you. I will take you as the internship in my laboratory. I will directly involved with my own research group, and they will if it after this internship, the institute, they will provide the internship certificate. Okay, as you know, it is a government institute, so the students, they will get a lot of opportunity in their placement, if you have these kind of internships. Okay, so in that way, I am also we are helping to the people. And another thing, recently I have one more opportunity. I am just recruiting one JRF, a junior research fellow, for my project. And if you want to work with this project, you can write the application, and the application procedure, it is available in the website, institute website. Okay, otherwise you can just write mail, I can show you. I can send the application. So if you want to work with under this project as a JRF, you can just apply. And this JRF position for 2 years, and per month will pay you for 31,000, and even you will get PhD degree also. Okay, so the JRF position also available for my project. So in that way, you can just try to reach out to my mail. I'm just always helping to the people for their betterment. Okay, so with this, I'm just concluding. So I have taken a lot of time. So thank you for your patience. And if you have any questions, so I can feel free to answer some of the questions, please.
Any questions from participant side?
Hello, sir.
Yeah.
Yeah, so you told that in diabetic retinopathy blood vessel segmentation, you are using expected maximization algorithm, EM algorithm. So according to you, how many iterations are more feasible to get the proper threshold value?
Yeah, so it is depends on the size of the image, and also so for my algorithm, I have been used 20 iterations, but always it may be vary from data set to data set.
Okay. Thank you, sir.
Yeah, it's a good question. Very good question. That the number of iterations, So that you have to be work with the problem. So we can't judge how many number of iterations. We'll keep on selecting the number of iterations. So once we can analyze the percentage of accuracy, so based on that you can select the appropriate iterations.
Okay, thank you, sir.
Yeah.
Sir, in diagnosis of eye-related ailments, apart from visual images, some additional signals can improve the diagnosis in some way.
Okay, what will be the question?
No, apart from using visual signals of the retina, if we include some more additional signals like the heartbeat or any other parameters connected, the blood pressure or things like that, can it improve our prediction in the diagnosis of the ailment?
Yeah, it is a good question. Actually, that is the different area of research. Actually, this fundus imaging research is everything in terms of the image processing perspective. Then we'll go for the another kind of signals, say for example this biomedical signal, say the glucose level and other kind of things. So that is different kind of research, because the biomedical signal processing, it is a different kind of research, for like this kind of prediction. What these kind of like our conventional hospital, say for example the diabetics hospital they have, so they will do that kind of biological analysis. But here again what happens is that in the biological image analysis, it is a very, very challenging job for research. Only the trained manpower, they can do that. Okay, and for the scientist or for the researcher like us, so that kind of biological signals, it is very, very challenging. But that's why for replacing those biological signal processing perspective, so everything we are trying to convert in terms of image processing. So with the help of image, how the possibility we can able to like predict the disease. Okay, of course, if you clubbing together, you will get some unique result or the better result. But like clubbing these two things, it is quite challenge. I never find these kind of clubbing research framework, because that is different area of research.
Thank you, sir. Thank you.
Hello, sir. Thank you very much for your very informative session on the retina. I just want to know कि while evaluating our result for abnormality detection for the fundus images, which particular data set we should prefer or refer?
Okay, it is also a very good question, Dr. Shilpa, I think. Yeah, so see here, actually, say if you want to work with any specific disease, so that we have to select the corresponding data set. Say for example, if you want to work with the microaneurysms, then we have the special data set is called the Mesidor. Okay, a lot of data sets are available, but as the researcher, our duty is to select the correct data set for the specific research. Okay.
Yes, sir. That is the very important.
Yeah, that data set you have to be select based on the literature. Say for example, if you want to work with this diabetic retinopathy with microaneurysm feature, then what you have to do? So you have to take a survey of diabetic retinopathy. Say how many publication, how many researchers they are able to contribute the the diabetic retinopathy with microaneurysm, and they will suggest you, like while taking the literature, you can able to find who is using the repeated data set. But I can tell you only in this case the Mesidor is the best data set, but that you can take it from the literature. If repeatedly the researcher is using the same data set, and that way you can select the corresponding data set, and also you have the advantage to select such data set for validation and comparison purpose. If repeatedly the researcher is using the same data set, then you will get lot of publication, lot of work to compare your work. In that way also you can able to do some good research.
Okay. Thank you, sir. Thank you very much.
Hello.
Yeah, please.
Yes, sir. My question is, as you said that in conventional image processing, we can contribute, we can find the problem statements and identify the gaps. And there we can contribute for some algorithms or segmentation, some unique way. But sir, my question to you is, so should we focus there? And this deep learning and machine learning will be the solution to those problems, right?
See, madam, see, in research perspective, these two are different end. Okay, say this conventional image processing and deep learning, these two are two end. Okay, so as a researcher, like the recently this deep neural network is outperforming well than the conventional image processing. That's why this 2020 era we have been always talking about deep learning like this. But actually, like the deep learning network, it may be the option, but our conventional image processing never replace anything else. Okay, so that these like the deep learning may be the option, like for getting the better solution. But now the things are changing. Now the deep learning networks are outdated now. The generative adversarial networks are coming. Almost many of the researcher, and we are also started working on it. And also the another one Chinese scientists, so they have been invented conditional gyan. Conditional, like the thing is that in artificial neural network, the neural network, the architecture will keep on changing. Like, so that may be the option for the prediction, but it never replace the conventional image processing. That will be the always the unique research for the scientist.
So sir, MATLAB is the only solution, or we can go for Python also?
Anything you can go, ma'am. Tool is not an issue. You can go for Python, you can go for any MATLAB, or you can go for this Google Colabs and Keras. No, lot of things are available.
The segmentation and all is done well in Python also.
Yeah, why not? Okay. Tool is the secondary. You can use any tool. You can use TensorFlow. That is also outperforming well than MATLAB. Yeah.
Sir, very good, excellent session. Very motivating.
Thank you very much.
Yes, participants. Any other question? Okay. So thank you, sir. Okay. Thank you. Really, very nice session actually. So, sir, as per the research, 60% population of India is diabetic. Okay, and really, your research work is a really great contribution to the society, because you have explained about what the diabetic retinopathy. Okay, the effect of diabetic retinopathy on retina. Okay, so really, sir, it's very good research. Thank you so much for sharing the key research problem and key research problem scenarios like the retinal images, MRI images, cancer detection, and all. Okay. Thank you so much, sir.
Thank you, madam. Thank you. It's my pleasure, and I'm very honored.
Thank you so much. It was a great time learning from you, and I look forward to further interactions with you.
Yes, sure. Sure.
College premises is very nice, sir. It's pretty beautiful.
Yeah, yeah. Thank you. You always welcome to the institute once things are normal. Okay, always the institute is organizing a lot of conference, TP frequently, and because of this pandemic, it is converted into virtual mode. And I hope I will collect all the participant mail ID from Dr. Radhika. So whenever things are coming, I will share to you, and in that way you can just visit campus once, at least in a life. You will get good experience in this campus. It's a beautiful campus.
Yes, sure, definitely, sir. And once the pandemic it's over, we would want you to visit our institute as well in Mumbai.
Yeah, sure. It's my pleasure. Definitely, I will visit.
Okay, so thank you so much. Thank you, participants. Thank you, Vijaya ma'am. You can wind it up, Vijaya ma'am.